Okay, welcome to ICE Education. My name is ICE. The only education that matters. That's my intro, by the way. But I'm shy tonight. I don't know why. Okay. But I'll still post it anyway. Let's not waste time. On the pulley, what the lecturer expects you to do, you use the Newton method. And
Tell everybody what BIG stands for.
yeah.
So
Again,
you're saying it's saying that you must use the energy method. You're saying we must use the Newton method.
yeah, we want to solve it using the Newton method. Either way, we can do it both ways.
Okay.
Yeah, but let's start with Newton method because that's what he expects you to do. Consider the system in figure Q1 consisting of a uniform disk M, radius R. Actually, energy method is even easier, but I know why I must. We have 2 hours now. I can do the two method in 30 minutes. I'll try to be fast. I do believe that you guys have some idea about what's going on. Do you agree that obviously they said the mass is connected to a pulley of inertia IP. This is the IP, right? And a spring of stiffness K and K2. So what they say K and K2, it's simply this K and this one was supposed to be K1. So it's basically K and K1. It's just a typing error. Don't really worry about it. And a massless cord, the disk and spring are pivoted at O respectively. Use the energy method to determine the equation of motion. So we're gonna do this using, I think, both ways, but I prefer the Newton method. But let's go. When you have something like this, my brother, have you seen a pulley? I'm pretty sure you guys have seen a pulley in Koketso. For those who have been, let's say, this is a bottle, this is something that has water, and you are here, you are pulling the cable. Have you seen something like this, my brother, in your life?
Yes.
This is a pulley. Now, there's a reason of what's happening here. During the pulley, you have tensions and reaction along the cord, the cable. So here you have tension 1, and you have an opposite reaction to it. Tension 1 prime. You've done this one in physics 1. Whenever we have a pulley, this is tension 2, and you have a reaction tension T2 prime. Why do you guys have this reaction? And there's a law that says that T1 must be equal to T1 prime, and T2 must be equal to T2 prime. Now, I was just trying to show you this relation because it's going to be important when it comes to solving this problem here. Now, here's the thing. My brother Zahir and Koketo. The only reason why we talked about this condition, it is because if the tensions in the pulley are not the same, this cable will break. That's the only reason. That's why you see in those who work in construction, when they work with pulley, they make sure that the cable's tensions are the same, like they are strong enough to withstand whatever weight. So just imagine in the case you have a pulley failing, a cord failing, it simply means that these conditions, they are not being met. That's why they do cable testing and so on in manufacturing. But the reason why I'm showing you this is in this our case, what's happening here, you will be having this tension here that we call G1, and you're also going to be having a reaction tension to it that we call G1 prime. So what does it mean? We'll be dealing with this system part by part. And please stop me where you don't understand. I will repeat myself. This is the G1 that you see here. You're also going to have G2 and a reaction tension to it, G2 prime. Now, I want you to tell me, guys, when we have a pulley, what type of motion do we have?
Angular motion.
Okay, you do have an angular motion on the pulley. Do you agree? Because it is turning.
Yes. Yeah.
When you reach this side, what type of motion do you have? It becomes linear. Do you agree also this side is linear? It's only rotational with those around the pulley here. Am I making sense?
Yes.
Yeah.
Now I want to ask you, how many forces are tangential to the pulley? Tangent simply means adjacent side, corner side. What are the forces that you see that are corners that are tangential to the pulley?
I see two forces.
Which
I
is
see the
T1,
two tensions.
the two tension. So it means these
Yes.
two tensions here, because they're attached to the pulley, they will create a rotational moment. I mean a rotational movement. This pulley will turn. Am I making sense?
Yes.
It means we can choose the direction to be as positive like this. I always prefer choosing going down, it's just a choice. You can also take it up as positive, but I believe it's easier like this for the consistency. Now, what's happening, Sisi, whenever you have a rotational moment, a rotational movement,
Yes.
that is where you talk of sum of all the external force about the pivot. External force to be equal to moment of inertia of your system multiplied by the acceleration. It is the same law of Newton. Remember, my brother, when you have a car driving, we used to say in physics sum of all the external force to be equal to the mass times acceleration.
That's acceleration.
This was for linear motion. This is for angular motion. But it's still the same way. So please pay attention to this and redo this even tomorrow morning or what, because I have a firm like my gut is telling me very high that you are expecting something like this on the pulley. Now, my brother,
Okay.
what is the moment? What is moment, Sisi? Definition of moment. When we talk about moment, we usually say moment is your force times perpendicular distance. This is the pivot O. Do you guys see it?
Yes.
What are the forces creating moment around the pivot? You cannot rotate without this moment here. What are the forces causing the moment here?
We said it's T2 and T1, and then
So-
obviously the mass, and
No.
I believe that
At
the
this point
spring.
here is only T2 and T1, only the two.
At which point?
On the pivot, the forces creating the moment are only the tangential, which is T2 and T1. We'll get to the rest after. Only these two. What I'm saying is,
Okay.
moment is force times perpendicular distance. So if T1 is down like this, do you agree the perpendicular distance is this one, right?
Yes.
What is
Yeah.
that distance to the pivot?
The radius.
The radius. So I can come and say I'll be having T1 multiplied by what? R. Is it
Radius.
positive or negative, you see?
The what?
The sign of this moment here, is it positive or negative?
I think is positive.
Why, Sisi? Let me not call you Sisi. Why Coquette? Sisi seems a bit like you also.
I think is positive because of the direction of the
That we
radius.
chosen. No, the direction that we have given. Just that.
Yes.
You keep the consistency. If you say this is positive, so what is the sign of T2? Remember, it's the constant
T2.
consistency of direction.
Yes.
T2 is negative, is opposing. Do you agree?
Yes, we agree.
And the distance of T2 to the pivot, what is this distance?
It's also the
It's
radius.
still the radius, yeah. I'm glad we are together. Minus T2 multiplied by R to be equal to moment of inertia of the system multiplied by theta dot dot. This is where we stop, my guy. We stop here. We don't worry about anything. Now, this is what's happening. We want to solve this equation. So basically what's happening is we need to make sure that these parts here are also part of this equation. Remember this relation. So we can come here, we deal with this section. Under this section here, guys, the one that I'm highlighting.
Yes.
Let me change the color. The one that I'm highlighting in red. What is the type of movement we
Yes.
have here? Is it angular or linear?
Linear.
Because this thing can only move up and down.
Yes.
So, what is the purpose of a spring force? It's simply to oppose the motion.
Yes.
And I'm pretty sure you guys have seen this spring, right?
Yes.
Yes.
My brother, do you drive a car, Mr. Zahir?
No, but I have driven and I am a passenger.
Alright, but as a passenger, have you been through a pothole?
Yes.
What happens when your shocks are not in good condition?
If your shocks are not in good condition, you probably feel too much vibration.
Or you can even die.
Like seriously.
I'm telling you, if you go, I've experienced that once. If you go at high speed and you don't have perfect shocks, when you hit a pothole, your car can turn, whatever. Okay, in simple way, if I can just say it, your shocks are the springs. They are here to withstand your weight, to bring balance.
Yeah.
They bring an
Okay.
opposite reaction to make you balance so that you don't feel whatever is there. So if this movement is going down like this as positive, I said we keep the consistency. Now if the movement here is linear, in this case we'll talk about sum of all the external force to be equal to mass times acceleration, x dot dot. I believe that you guys know that acceleration is x dot dot, velocity is x dot, displacement is x. Do you know that, Sisi?
Yes, I do.
This is we've done this in mathematics 1 and 2. Now basically what's happening
Yes.
here, you recall all the force that we see here, the way you see it. You don't have to think much. You have already chosen your direction. Now what is happening here?
Yeah, with numbers.
What is happening here? If this is positive direction, what are the forces going in the same direction as this one?
It's the weight.
It's not the weight.
Okay, we'll be having a weight, but you will see it will cancel as static equilibrium. We have the weight minus
The tension
the tension
minus
minus the F spring. Remember, the spring force will oppose the motion
Yes.
to be equal to m x dot dot. It's fine that you have motioned the weight, but the simple reason why we don't usually include the weight in this equation, I think that's something that I've mentioned in class, is when you have a system horizontal like this or vertical like this, the weight does not really affect your equation. Let's say a ball like this, because it cancels at static equilibrium. I will just explain right now what I mean. But if you have something like a pendulum, do you see the pendulum, my brother? Right?
yes.
When it swings,
Yes.
it creates a different, it creates an height. These two masses are not in the same position. This
Yes.
height creates potential energy. So because the weight is creating potential energy, in this type of scenario, the weight will affect the motion. Now, in this scenario here, because this thing is only going up and down, is not creating any potential energy. That's one of the reasons we say that weight cancel at static equilibrium. Do you know what is static equilibrium, Sisi? Okay, I will explain what is static equilibrium. It means you are partially at equilibrium. If this is the ground, right?
Yes.
You are standing here on the ground. Can you fall?
No, because you're standing
you
on the
are at
ground.
equilibrium. You are standing, right?
Yes.
Okay, let's say you are now laying down like this. Let's say this is you laying down. I'm not good at drawing, and someone is here, is the one carrying you. How will you feel?
Like you wouldn't be balanced.
We call it static equilibrium. It means you are trying to find balance, but you are not balanced.
Mm,
You have the
yes.
tendency of shaking.
Yes.
Yeah, that's what we call static equilibrium. So when we are at static equilibrium in this case, why am I saying that? You see, this system, the way it is, can it be at equilibrium? Let me just take an example. If you have a cord in your hands and you put, let's say, whatever, a ball, what's gonna happen?
Like that ball will be moving around my hand,
It will try
trying to
to
find the
pull it
balance.
down, right?
Yes.
Until you try to balance it, because it means the system that you have cannot stand still. We call it static
Yes.
equilibrium. So when the ball is standing here, what are the forces that you see at static equilibrium before making a movement? You simply see what? The weight. Am I making sense?
Yes.
That's one of the reasons when you choose a direction to let it go, weights cancel at static equilibrium. That's just the reason why we do not include it in such cases. But in a case where the weight creates potential energy, which I have shown you, where you have difference in height, let's say it was initially here, as the thing is rotating, the weight is here, because there is a difference in height. Be careful, in such instance you have the effect of the weight.
Okay.
So in this case, we're gonna call this one T1 prime. Remember, it's T1 prime. So now we're gonna cancel the weight because we know it goes at static equilibrium. So what we are going to do here, we will make T1 subject of the formula. I need to finish this quick in both cases. Fs minus m x dot dot. Now you do make T1 prime.
Minus mx.
No, what is it? Is it plus? Like this, right?
Plus.
Yeah, thank you.
Yeah.
So we have minus fs minus mx dot. I have a question, guys. What is this mass here?
It's the mass of the ball.
The mass of this ball here, because this thing is creating an acceleration.
Yes.
That's the mass of this ball. Thank you, my brother. Now remember, we know that we said T1 is equal to T1 prime. What we're gonna do, we're gonna take this and replace it. That's all. What is it about? But before we do that, my brother, do you guys understand what I'm doing?
Yes, we see.
Okay. No, working.
Sir, I just wanted to confirm something.
Yes.
The T1 and T2, is it always directed away from the pulley?
Yes.
Okay.
Thank you. It's always directed away. Now, my brother, you also have this part of the system here, right?
Yes.
Do you see any masses here?
No.
So what does it mean?
No.
You don't have an acceleration, right? In this case here, all these forces
Yes.
will be equal to 0. It is equal to mass times acceleration because there is a mass in this case. Do you agree?
Yes.
There
Okay.
is no acceleration here. It means this part here is basically at equilibrium. So how many forces
Okay.
do we have here? We have,
How many more?
how many forces do we have in this case here?
We have 2 forces.
Remember, this is the positive direction, so the spring will oppose this way.
Yes.
So we have negative spring force plus what? T2 prime
Tension.
to be equal to what? 0. Now I have a question here. When you have two springs like this, what do you do?
You combine them.
Yeah, you find what we call K equivalent.
Yes.
The K equivalent for spring in series, they behave like resistor in parallel.
Yes.
I believe that is like this: 1 over k plus 1 over k, and then you multiply by the inverse like this. Yeah. When you have two springs parallel, what do? You add them for k equivalent. You'll add k
Yes.
plus k. Yeah, this is just a bracket to see what's happening here. So if we come back from
But sir, by K1 there's no K equivalent. It's just K1.
is alone,
Yeah.
you solve the equivalent. You see this dot, it means it's two springs together, it's not one spring.
Yeah.
This one will stay like this. So to make the
So
difference,
so parallel is when they are next to each other, right?
yeah, I think I can show you here. Yeah, this is parallel,
That's parallel.
this parallel, this is
So that
series.
sharp.
Okay, thank you my brother. I need to move a bit faster. So if we come back here, we definitely say that, can I call this one fs2 just to make the difference? This one fs1 and this one fs2.
Okay.
So fs2 will be equal to what? To g2 prime. Do you agree, Sisi?
Yes.
Now remember, there's a relation that I've said in the beginning where these tensions are the same. G1 to be equal to G1 prime, G2 to be equal to G2 prime. So basically what we're gonna do, Sisi, we're gonna take T1, you replace T1 prime, you replace where there's T1 in this expression. T2, you replace the what you have here, and then you have your equation. As easy as it is, just how it is, that's how you solve it.
Wait. You are saying we are replacing what?
Do you remember this equation of the moment?
Yes.
What do we have? T1 multiplied by R minus T2 multiplied by what?
By R.
Now, we do have this relation here of tensions.
Yes.
Do you have T1 prime? Do you have T2 prime?
T1 prime. Yes, we have it.
What did we say?
We have T1 prime.
We said T1 equal to T1 prime, and T2 equal to what? T2 prime.
Okay.
So what we're gonna do?
So we're just replacing with T1 and
What
T2.
that's the same principle. If you understand this, you should be fine tomorrow. It's
Then
all
from
about
there maybe it will turn
to the equation.
into a simultaneous equation.
Not even simultaneous, we're gonna have the equation of the motion. Let's see, you see. So what's
Okay.
happening is this equation here, where there is T1, I will write this expression here. I will write minus F1, Fs1 minus mx dot dot. Remember, it is multiplied by what? R. It is T1R. Do you agree?
Yes.
Wait, so where did you get that now from
Remember-
T1 prime?
Yeah, remember T1 is equal to T1 prime. So where I
Yes.
have T1 prime, I will just put it here. Where there is T1, you just copy and paste.
Yes.
So basically, we are substituting.
Yeah, to get
On
the
that
equation of the
equation.
motion. That's definitely it.
Okay.
So here I have minus. What is T2? T2 is Fs2
Yes.
multiplied by what? R,
Ah.
to be equal to moment of inertia of the system theta dot dot. Let's move guys. You see, energy method will be quicker and we can do something else as well. Now
Okay.
Okay.
now I want to move a bit fast. Remember, what is the spring force? It is K times X. Do you know what is
Yes.
K, guys?
Is the spring constant?
What is X, my brother?
This is actually where the question. I actually have a question. I know that X is the displacement from the equilibrium position.
Okay, my brother. You said you've seen a spring, right?
Yes.
If this is a spring, when you pull it, what happened?
Stretches.
The stretch is here, it creates a distance x.
Yes.
So to get the force of the spring, it is simply the constant of the spring multiplied by this displacement. Now, here is the thing, my brother. You see this system here? It rotates. Do you agree?
Yeah.
Now, it means the spring will have an effect. If this is my rotational, right?
Yes.
If I was here initially and I've pulled, let's say this side I had a spring, right? So it means I will
Yes.
be moving through a certain distance here. Do you see it? It's a circle.
Okay.
I am here. This is me in
Yes.
the beginning. When I make the movement, I stretch.
Yes.
When I stretch through an angle. Remember, if this is R, if I move a certain distance, I will still be R.
Okay.
Please pay attention, I will come back to it. The distance that I stretch here, it is the X created by the spring. If you remember when you guys were doing Math 1, you had something like this. You had a center here and they were asking you to solve for arc length.
Yes.
You guys were calling
Yes.
it S. What was arc length? S was what? Arc theta.
Theta R. Yeah.
It is the same thing. Your S here is simply X, the one that is stretching here. So X is equal to R theta.
Oh, but sir, how it seems like you get that question a lot because I didn't even really ask the question and you answered me.
I've get it a lot.
Yeah, because I wanted to know why does it go from kx to, let's say, kx squared times theta.
You will see where the square comes from. But
Okay.
it's not even that the square come, you will see where it will come. But simply what I mean is the stretch X here, it will simply be what? Big R theta. Remember, it's the radius, right?
Yes.
This is where you get it. Remember, because the spring is like this. Only when you move the system that you will see your spring is stretching. Because as it stretch through a certain distance x. But because here we have an angular motion, it can only move as a circle, as in we call it arc length in mathematics. It can only create an arc length. That arc length is r theta. Are you with me, guys?
Okay. Yes.
So let me try to write. Please, I hope you are writing down as well.
Yes, sir.
We have minus where there is a here. I can call it k1, right? The k equivalent. I can call it k1. No, let me not. No. Please, let me see what I'm writing before I say something. Okay, this one I call it k1, and it's k1 here. Yeah, it's making sense, right?
Okay.
It is k1 multiplied by what? Multiplied by r theta. Do you agree?
Yes.
The formula says F is equal to kx. Do you agree, Koketsu?
No, I don't get it.
Okay. Remember we said force of the spring is equal to what? Constant multiplied by what?
The displacement.
What is the displacement in this case?
R theta. Okay.
So do you agree that I can write it like this now?
Yes.
Okay, thank you. If you are with me, I'm happy. Now, what do we have here? Minus m x dot dot. Remember, everything is multiplied by r. Okay, my brother, do you see where the r square comes from, my brother?
I see now, yes.
It's simply when you have a moment. I want to say it in the way that you'll understand me. Remember, moment is what? Force times perpendicular distance, right?
Yes.
The perpendicular distance that you have, it will also be the radius that will be stretching that will be stretching. What's the English I'm saying again?
The perpendicular distance that you have will also be the radius that you'll be stretching or something.
Okay, what I'm trying to say, remember, when the spring move as whatever that it stretches to a distance x. Am I making sense?
Yes.
What I'm saying,
Yes.
the stretch that is being created, you see, this is r. That when the force was here, we said moment is what? Tension times what? R. Do you agree, my brother? Now,
Yes.
what did we say about x? X
It's
is r what?
R.
Theta. What I was saying is the distance that you use to find the moment. In all the cases on this chapter, the distance that you use to find the moment, right?
Yes.
It is the same distance that creates r theta.
Okay.
Okay.
I don't know if my
So
English.
basically, there's a moment there, and there's a kind of a moment at the bottom as well.
No. Don't think of it like that. I'm just trying to show
Okay.
you that this. What I'm trying to say, when you develop your equation, you will always have something square. Why am I saying that you'll have something square? Because I'm repeating, when in all the cases, moment is what? Force times what? Perpendicular
Perpendicular
distance. Am I making sense? When it comes to solving the spring or a damper, depending on the case that we have, we know that S is equal to what? R theta. Am I making sense? Now,
Yes.
what I'm trying to say, the distance that creates the moment, that distance, it will be the same distance that will always create r theta. If you don't
Okay.
get it, don't worry, you will see what I'm saying.
Okay.
Don't worry. I know sometimes my English is bad in my mind. I can't say it properly, but I'm not that great. Okay, my brother. What is FS2?
It's the K equivalent there, so it will
K
be
equivalent?
K
What?
over 2.
Okay, you will do the calculation after. I don't know. I'm
Yeah,
just catching K equivalent. But what I
K
know is this
equivalent.
one. Yeah. It's K equivalent. Now, what is the. Remember, it is KX. All the cases. What is the X here, my brother?
The X.
In this case. Remember, we are here. Let me erase here. What is the X? If this thing moves, let's say it was here,
Yeah,
right, and it has moved here, it creates what angle?
that angle, yes.
What is this X here? It's still r
That is
theta.
R theta
It's
still.
still r theta.
Yes.
It's not changing. Do you see it, Kokezo?
But
Yes, I see.
but obviously, can we use the same symbol like theta now for another angle, or is it like
No, you keep the same angle because those two they will create the equation. You don't use alpha, beta, no. How
yeah?
about
Okay, okay.
you keep the consistency?
Yeah,
But are you consistent?
yeah. Me, I want to also be consistent in theory of machines.
In other aspect, are you consistent? Or are you
Yeah,
the
I am.
guy who buy flowers only on the first date?
No, I am consistent when it comes to dates. I'm consistent when it comes to work.
When
I'm
you get
consistent.
what you want, I don't give flowers anymore. Remember,
You.
it is r theta and then multiply by what? This r here again. Do you see it, my brother?
Yes.
Yes.
To be equal, let's move fast, please, God. I need to cover. Okay, what's happening here? Do you guys agree that the r will come inside here, right? You're going to have minus k1 r square theta.
Yes.
And Mr. Kaye, this is where you see the square in most of the equation that you work on.
Yes.
The square does not come from claiming. It comes the distance of the moment when it meets the r theta. Minus m x dot multiplied by r minus k equivalent. What is r times r?
R squared.
Ooh, sorry, guys.
Yes.
This should be posted on my YouTube channel. To be equal to moment of inertia. So please subscribe, my brother. I will make sure that, because for my online classes, I usually keep it private. I will send to the people that work with me private to get the chance to see it again. And those who don't pay, they don't have to see it.
Yes.
Okay.
No, but honestly speaking, like you're really helping. Like, imagine if we working every day and stuff like that, because like the cramming is definitely not gonna work. But this is like exactly how we're supposed to do it, by using your fundamental principles and then working from them.
Nah, thanks, my brother. How's the class so far? It's not bad, ne?
I,
Yeah.
I'm enjoying, sir.
Okay, thank you. Okay, guys, let's try to move a bit faster here so that we can move to the other thing. What I'm trying to see, the equation of the motion, what we do, we bring this guy here and we equate it to 0. It's just as simple as that. But now there's something that I wanted to show you. What is the displacement? You guys said x is equal to what?
R theta.
What is the velocity? It's simply r theta dot. Okay, I'll come back to it. I will explain. In mathematics 1 or in physics, you had something like this. You had function f of whatever is equal, let's say, chi square plus 2chi plus 4. I remember this in math. This was taken as the displacement, x of chi. When you were asked to solve for the velocity, you were differentiating x like this in terms of time.
Yes.
That was giving you velocity. When you wanted the acceleration, you were differentiating in terms of time x dot. It was giving you x dot dot. You've done something like this in mathematics, and it is the same thing here. But here on your level, they don't expect you to do long equation and prove what is there. But what you have to know is, if x is equal to r theta, what will be x dot? Simply r theta dot. The only reason why r is still here, because it's a constant. You're only differentiating theta. Because you are differentiating in terms of time, theta becomes what? Theta dot. If you want to get x dot dot, what will be the expression?
Theta dot.
Okay, do you know the reason why I'm showing you that, guys? I want to skip the consistency. This equation is made in terms of theta. I cannot have theta and also have x.
Okay.
So it means here I will have minus k1 r square theta minus m, where there is x dot, I will replace by what? R theta dot dot, without forgetting this.
Wait, sir, let me just see that. You replaced x with r theta. No, it's x dot dot.
It is x dot dot.
Okay, so x dot dot, you replaced with r theta dot dot. Okay, fine.
Yeah.
Yes.
Now I was expecting you to ask me a question like, why not this small r of this thing?
Why not the small r?
Because this disk here has a mass and small r. Because the r here is the radius of the disk. When we are talking of full motion, we are referring to the pulley. That's the only difference. The r here is simply used to get the moment of inertia of the disk. We'll get there when we are.
Okay, so meaning that we're still on the right track. We don't have to involve small r yet.
You will see when we use it.
Okay.
Are you with me, Sissy? Okay, so are you with me?
Yeah, I'm listening.
Okay, let's go quickly. Key A r square theta to be equal to moment of inertia of the system times theta dot dot. Remember, we want to write this equation. So what I will do, I will bring all the guys on the other side. I will keep the consistency. I will have I of the system plus m. Remember, r times r gives r square. Do you guys agree?
Yes.
Theta dot dot. I'll keep the dot dot together. I'll keep the theta together. So here I can call it plus and say, what do I have here? K1 R square. Let me do this like this. K1 plus K equivalent. Everything multiplied by R square theta to be equal to 0. Okay, what I've done is, guys, remember these two, they both have theta and theta. So I can put them
Together. Yeah.
They have common factor, R square theta. I just put them together.
Yes.
And I added them because they're on the other side. And when we write the equation, the rule is to leave theta dot dot alone. I'm pretty sure you have an idea what I'm talking about. It's a differential equation. Do you know why we call it differential equation? You've done differential equation in mathematics, math 3. Hey, my brother.
It's a differential equation because it has derivatives as terms.
Thank you. You leave this guy alone. When we solve, we usually leave this guy alone. The simple reason is this is R square, this is theta, to be equal to 0. The simple reason we leave it alone, because it helps us to get solution of what we need. What do I mean by that? The expression next to theta here will always be equal to Wn square. Do you get me?
Yes.
If you read the questions, you see, after here they will say calculate the damped frequency, whatever it is. Everything comes from this one here. So Wn square would be equal to K1 plus K2, everything R square divided by Is plus M R square. Now, before we move to the solving, this is the differential equation. I wanted to ask you, what is Is?
Is.
Is moment of
It's
inertia
of the system.
of the system.
Sorry, sir. Going back there quickly to the differential equation.
Yes.
It's theta then, eh? You underline theta.
Yeah, this is theta.
Okay, and it's equal to 0. Yeah, that's all.
Please, guys, we do this before we sleep. I know.
So, sir, I wanted to know, for the moment of inertia, we only got that one thing that is contributing to the moment of inertia, and it's the small mass.
Okay, I wanted us to read the problem. You see the problem, they say the pulley has an IP. That pulley has moment of inertia.
Sorry?
They said the pulley of inertia IP. It's even written here.
Yeah.
Yes.
So it got inertia IP.
It got its moment of inertia.
Okay.
This is the center of this is the moment of inertia of the pulley. Now here's the rule that I've said even in class. I know you guys are working. I said when you have such a problem, you see all the masses that you have. Number of masses gives you number of moment of inertia. How many masses do we have? How many?
Only one.
I see one mass.
Which is the disk, right?
Yes.
Yes.
But this is here we are also given the moment of inertia of the pulley. It's given. Do you agree?
Okay. Yes.
So in this case here, Is would be I pulley plus I disk. Are you with me, guys? On this one?
Yes.
Yes.
But I pulley is given, it's a value, we don't have to worry about it. What is more important for me is how to get I disk. What is the moment of inertia of the disk? It is half mass of the disk multiplied by radius of the disk square. is coming out here. Let me just check the time. I know this link close. I have 11 minutes to explain this. I have a lot of time. Let me close this thing here. See, do you know that moment of inertia of the disk is this one?
Yes.
Now, this moment of inertia is found when the center of gravity is passing through the center, is passing at the center of what? Of the disk. Am I making sense?
Yes.
Yes.
In 2D, you look at it like this. This is the center of gravity of the disk. Now, here's the thing about this problem. Why do you think we do have this here? Let me erase again. Online class are nice. I cannot. I'm just touching my thing, not even messing up my hands. Now, what I wanted to show you is, what is this point O here, my brother?
It's the pivot.
What does the pivot mean? It is called axis of. It's the reference. Do you know what's the reference, my brother?
No.
Why when you go to the bank, what do they ask for your ID? Your ID is your reference.
Okay.
Everything in life we need a reference, a point
A
that we
reference.
refer to, and in such problem, your pivot point will always be your reference. What do I mean by that? You know that this is a disk. When you have a disk, when the center of gravity is passing through here, to its center, or let me say the pivot point is passing through its center here, what do we have? We have I to be equal
Half.
to what? Half mass r square, right? Now,
Yes.
for this problem here, where is the pivot point? Do you see it, guys?
Yes.
Where is the center of
Ah.
the disk? How are these two lines?
But sir, what makes you draw the vertical lines and not the horizontal lines?
What makes me draw the vertical lines, not the horizontal line? Anyway, let me do this. Your question is, why not drawing like this? Is that your question, my brother?
Yes, sir.
Okay, the only reason is because this motion is going like this. It's turning to go to the up. It's not moving up on the horizontal.
Okay.
It's because this thing is moving up and down. That's the only reason. I hope I've
Okay.
answered you. But what I wanted to show you is, do you see the pivot here, my brother? This is the axis of rotation through the pivot. Do you
Yes.
agree? This is the axis at the center of the disk. How are these two lines, my brother?
It's R.
How are they? What's the nature of these two lines?
They are parallel.
Because you see parallel lines, it simply means that you are having what we call the parallel theorem.
You.
Okay.
This is where you talk about parallel theorem. It's easy because the lines are parallel. What do I mean by that? I think you need to understand the parallel theorem as well. It's important, and you'll be having it throughout this chapter. If you have a bar, right? This is
Yes.
the center of gravity of the bar. Do you see it, Sissy? Moment of
Yes.
inertia of the bar, we said it is 1/12.
12
Mass of the bar,
M
left
L
side.
squared.
If I put my pivot point here,
Yes.
do you agree that this is also at the center, right?
Yes.
So
Yes.
it means moment of inertia in this case will be this one. What happens when the same bar is here and the pivot point is here? What do I do? What is the center of gravity of the bar? In the middle, right?
Yes.
On its own. This is it. What is the axis of rotation?
It's at the origin, at
At
the
the
beginning
corner.
of the bar.
What are these two lines?
It's up. It's
Then
parallel.
you have parallel axis. In this case, the moment of inertia of the bar is going to be what you know, 1 over
1
12
over.
mass of the bar length square plus the
Mm-hmm.
plus mass of the bar again, the distance where the center of gravity of the bar is to the pivot square. Let's say everything
Oh,
was L, so let's say this distance is L over 2, so you will have L over 2 square. So you have parallel theorem only when the center of gravity is not placed at the center of gravity of your object or shape.
But
okay.
sir, why do I see in some examples now when they put a ball mass on a beam, then they don't when they do the moment of inertia of the ball, then they just do the distance directly. They don't
I want
add
to
the
no.
radius.
I want you to show me one here, and I will explain. I don't just show me. You see me
Like
scrolling.
maybe like
It's
even
4
that one
minutes.
that you were showing now, it's fine even.
Even this one, it's 4 minutes. I will
Like
send a new link, but let me explain
okay.
this. You need to understand this. It's very important. Okay, you are saying, my brother.
Yes, you can go back to that question there, sir, by the Simon.
Oh, which question?
Yeah,
This one.
that one is fine. So, see from the pivot, ne,
Hmm.
the that mass is 80 mils
Hmm.
from the pivot.
Hmm.
So, when they're gonna do moment of inertia, they do it directly mass times 80 mils
No,
squared.
no,
Like they
now
don't
you have to
add
read.
the radius.
No, you have to read. What is the nature of this mass? If you read the question, the figure 2 is 2 meter carries AB. They say the sphere has a mass and 8 kg
Eight.
and radius. No, you have to add.
No, oh, you have to add. It's just that when I was doing some questions and examples and whatnot, then I saw that they're not adding it. They keep not adding it.
No, 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 no. It means something is wrong.
Okay, no,
You
perfect then,
understand
sir.
the question, Kaketso?
Yes, I do get it.
You have to add the radius because you are saying, let's say,
Okay.
you have a disk here, right?
Yes.
And you want moment of inertia of this disk. You will write half mass of the disk radius what square, right? Plus
Yes.
mass of the disk. Now you take the distance. This is the center of gravity of the disk. This is the pivot. What is the distance? You first have r,
R.
and then you have this distance. Let's say it's L over 2.
L over 2 plus L over 2
I think
squared
what people do confuse sometimes, you can also have a disk and the bar is entering through the center.
through the center. Yes, I
In
Mm.
this
understand.
case,
I
you'll
understand.
have this m, the distance from the center to here. If it is L, it's gonna be L only.
Yes, sir.
But if it is at the edge, you add this radius.
I know. I'm clear on that. Thank you, sir.
Okay.
Now I want to send a new link because this one will close in 4 minutes. I'll just send a new link and we come again.
Okay,
It's
sir.
not
Okay.
gonna take long.
Okay.
Sharp. You see, okay, so it didn't take long. Now we can
Yes.
go again. You see that people have to pay for such content. It can't be.
Yes.
How is the class so far? Are you enjoying it? Or are you understanding what we are doing?
Yes, so far so good.
Please redo this question. Yeah.
Mm.
You must.
Okay, I'll do.
This one's burning.
What are we doing now?
I want to finish this question and we. I don't know if I should do energy method, but I will explain to you quickly. But you will not have energy method. I'm also thinking,
Okay.
where you work, do you guys use software like AutoCAD, Revit?
No, no, where I don't use it.
Hmm?
Where I work, I don't use it.
Oh, I thought when you work, where you work, you do music.
No, I don't use it.
That may be a GG.
Okay.
Where is this guy? Where is Mr. Kafir? Kafir.
How many questions should we expect? 2?
Guys, 2 questions. 2 or 3, but not difficult question.
Yes.
The test will be easier. It
Okay.
will be easy. Hey, Mr. Zahir, did you subscribe?
Let me have a look, sir.
No, but anyway, you can check after the class.
Yeah, no.
You went there to my class, you saw vibration, you were like, let me try to master this. My friend, that's.
And then I see steady state, and then I'm like, man, I never heard of this stuff. Is it because I didn't attend?
No. Those ones they are even. My content is not professional yet. I think I need to improve it. I don't edit. You see, like this, I'll post it like this. So it means if what you are saying is bullshit, just know your bullshit will be on the internet. That's why I mind my mind when I do this recording, because I can say something. Okay, none of the less, you've seen what we mean by parallel, right? And I'm pretty sure you saw what you asked for, Mr. Zahir.
Yes, sir.
Okay, in this case here, you will take your calculator after. What I wanted to show you, moment of inertia here for the disk is going to be mass of the disk plus now. What is the distance? Oosh, what's happening? The distance where the center of gravity of the disk is to the center of gravity of the pivot. What is this distance?
It's R.
It is R. It is the same R that you see here. It's the same distance. That's why we do have the small r. That's why you will see the small r. You do have the small r for the disk, but this distance here is r squared. It is simply due to parallel theorem. Am I making sense, guys?
Yes.
Yes, sir.
So this is gonna be on you. What you need to do here is to get a moment of inertia of the system. How do you do that? You have IP, you have ID, you have all the distances, you have everything given under this problem. Where's that problem again?
Wait, so I'm a bit. What? How did you get IP? Half of the disk, like.
No. IP, I didn't write any formula. IP, the same. The pulley is IP, and the value of IP here is here.
It's gonna be given, yes.
It's here, 0.8. You don't need to do any parallel. The moment of inertia here of this pulley here is this one. Is when they calculate to the center of gravity of the pulley, they got 0.8 under this problem.
Yes.
So you don't have to make any formula there. You will just take 0.8 plus you add everything that you have here. Half. What is the value of the mass? What is the value of small radius?
Yes.
You go again. Square. Plus
Square. Yes, sir.
that mass. What is big R? Square. That gives you moment of inertia of the system. The unit is kg meter square.
Yes, sir.
Now, once you have IS, it means you can solve everything here. Now, what is the question? The question says calculate the undamped natural frequency. What is the undamped natural frequency, my brother?
Z omega n.
Yeah. Okay, what does undamped mean even?
Undamped means there's no
There's no
damping
damper in
coefficient.
the system.
Yeah.
So why do they say that? Why they say undamped? Sometimes in the question they can say solve for the damped. You can only have the damped in a system when you have a damper. For instance, this type of system. If I see the damper here, this question they say determine the frequency of damped. It means the frequency of the damper, and there is a formula for it.
Yes.
The formula is linked with Wn. But in this case here, what they said, determine in hertz. How do you determine in hertz?
You get the natural
You get
frequency.
Fn is equal to Wn divided by 2 pi. You're gonna have your answer in hertz. Remember, Sisi?
Yes.
Here, you're gonna
Yes.
put K1, K, whatever. The answer that you'll get will be rad per second.
Yes.
Now, this is it. If you want to do energy method, I'm just gonna explain quickly, but you will not expect something like this. On the energy method, what you need to know, they said E plus U is equal to a constant. That is the rule. E is
Yes.
kinetic energy. Now, in such system, you have kinetic energy. It's simply due to moment of inertia. Now, you have half high pulley theta dot square. In physics 1, or mathematics, let me not say math, physics 1 or 2, when you talk about kinetic energy, you guys were saying K is equal to half m velocity square.
V square.
The only reason why it was velocity square because the movement were linear.
Okay.
If you do have an angular, it is half ip theta dot square. Now, how many ip do you have? You also have half height of the disk theta dot square.
Okay.
Now, another height that you have here, it is also the disk, but now remember, because the disk has this moment of inertia because the disk rotates. In this case, remember, the disk is also creating a linear. How does it create a linear? Remember when I was doing this, I've told you that this part here, you have mx because there is an acceleration created. There is a mass here. Do you remember, guys?
Yes.
Yes.
Because the disk here is the origin that is creating this acceleration, is also creating a linear kinetic energy. Now, you come to the K. K is simply, U is simply the springs. It is half K, let me say K1 x square plus half K2 x square. If you can do this, the rest is easy. So what does the rule say? It says when you differentiate in terms of time, E plus U, it gives you
Yes.
0 because this one is a constant. Differentiation of a constant is what?
0.
From here is just mathematics. Now, what is happening? You see, what you are differentiating in terms of time is simply. Now, let me be smart. Why I used to work smart? Why am I not working smart?
Copy and paste. We're using pens, sir.
Control C, Control V. Yeah. Why should I work harder?
Well, there are shortcuts.
Why is this? It's not like I'm writing on the board. D in term of time of this. Now plus, remember, you have half k1 x square plus half k2 x square to be equal to what? 0. Remember what I've told you guys. When you have a time as variable, if you differentiate theta, it gives you what? Theta dot. Now, do you guys remember the chain rule in math 1?
Yes.
Sorry, but there's a lot of math. Don't worry about energy method so much for now, but let's
Yeah.
do it. You have u to the power n. It says you have n u prime un minus 1. I will just take 1 and the rest will follow. Please pay attention. If I have here theta dot square, do you guys agree?
Yeah.
What is
Yes.
my n? 2. So I drop 2. Do you see it?
Yes.
What is u prime? Remember, this is theta dot. What is u prime? What is differentiation? Remember, it's in term of time.
It's double dot.
It will give theta dot dot. And the formula says un minus 1. So it means you repeat again. Theta dot multiplied by what?
Dot.
What is n minus 1?
1.
1. So this is the derivation. Everything will follow like this.
So the answer is 2 multiplied by theta dot dot.
times theta dot.
Okay.
But
But
remember,
that would have been an easy mistake to make, sir. Like, because you normally need brackets to do the chain rule.
remember, you only have the chain rule is when you have a power. If I write theta dot square, it is the same as theta dot square. He met. Now it's met, you see. Whenever you have a power, that's what you use. The only way, the rule is simple. You use the chain rule when you have a power. When you see
Okay.
something with a power.
Yes, sir.
Hey, but I'm very good in math.
I myself, I'm not too bad, sir.
What's happening here? When you drop the 2 will cancel the half.
Yes.
Do you agree, Sissy?
Yes.
Yeah, so you don't have to worry about these two. What I want you guys to worry is the first expression here will be IP
IP
theta dot
dot
multiplied by this.
theta dot
The following one will be the same.
Yes.
ID
ID
theta dot
theta dot
multiplied by theta dot.
half mass of the disk. Guys, we're gonna do the same thing here. Same thing. Can I remove the half
Yeah.
here?
Yes.
Can I? Do you agree with me?
Yes.
Because the 2 will fall there. MG, do you see it? What's gonna happen here?
Yes.
Here, you're gonna have
X
dot x dot.
X dot.
Yes.
Now, this one here, the half will cancel. This one is even easier. But do the Newton method. What do you have
Okay.
here? You have
K1
x dot
Dot.
x.
Dot.
X dot X.
The 2 will drop. You have x dot and then you have x.
K2 X dot and X. Yes.
Do you see it, Sissy?
Yes, I
Still
see
the
it.
same rule. K2 is what? Same thing. K2
Yes.
x dot
X
what?
dot.
X.
To be equal to what? 0. Now, what can we do?
0.
Let's move quick. Okay, remember the relation that we do have. I want everything to be in the same variable. forget about this theta. I was just trying to use my finger. Let me erase. There's nothing here. Okay, guys. What's happening? Remember, I said x dot is equal to what? Do you agree?
X is velocity.
And what is x? R theta. Is it fine?
Yes.
Yeah.
That's what we're gonna do here. So wherever, can I repeat here? Okay, let me just repeat. There's no problem. You have to. I don't wanna skip step. IP. What do we have here? Theta dot dot times what? Theta dot. Do you agree?
Yes.
Plus what? ID. Theta dot dot.
Theta dot.
Okay, plus let's start replacing MD. What is X dot?
X double dot is R double dot.
Do you agree?
Yes.
What is X dot? Because this one has to be X dot on its own.
It's
X dot
R
is-
dot.
is R
Theta
dot.
dot.
Are you together, guys?
Yes.
Yes.
Now, what on this one? Plus K1. What is X dot?
R
Theta dot.
theta dot.
Dot.
What is X?
R dot.
R
Theta.
Same thing. K2. What is X dot? R
R
theta
theta.
dot. Multiply by what?
R
R
theta.
theta.
Okay, there's something that I see all of them have. What is that?
Is R theta.
Now it's theta dot. All expression here.
Oh,
Theta dot.
theta dot.
Do you agree?
Yes.
So we can
Yes.
come here and write theta dot as common factor like this. Are we fine, right? Now this one here, can I make them together? All the theta dot dot theta dot dot theta dot dot.
Yes.
I'll be having high P plus
Theta.
high D
IP plus ID
Plus MP.
M.
M
Remember, it's gonna be R square. This R and this R.
plus M R squared.
Is it confusing you?
No.
No.
Do you agree it's gonna be like that, right?
Yes.
Multiply by what?
Theta.
Theta,
Theta.
dot dot.
Dot dot.
Now,
Theta dot dot.
remember theta dot is outside. Can we do the same with this K here? You'll have K1. I can even put them together. K1 plus K equivalent if you want. Remember, what is this one? Theta dot is outside. You have R times R, it gives R square. Do you agree?
Yes.
Also, this
Yes.
R times this R square. So you have
Yes.
R square theta to be equal to what? 0.
Three,
Now,
zero.
what do we have?
We can cancel that.
Theta dot will be 0. Do you agree?
Yes.
This
Yes.
equation also here will be 0. So if I can write it quickly, do you agree if I make theta dot dot alone like this, we'll have K1 plus K equivalent, everything, high pulley,
ID.
high disk, plus M R square, theta to be equal to 0. You do have the
Equals.
same expression.
Yes.
Yeah, it's the same.
Why is it again? Ish, why am I zooming bad like that? You do have this expression. Remember, what is IS? IS is IP plus ID.
Yes.
You do have the same expression. So this is the energy method. That's the Newton method. So choice is yours. And if you do them right, energy is quicker. But
Yes.
from what I know, you won't be asked energy method. You will do it using the Newton method. So my brother, I just did the energy method because I did not want to run away from the question. Otherwise, you'll have it.
Yeah, no problem. And the thing is, like I like to know how to also verify my answers. So maybe if I have a chance, I'll try energy method to see if I'm correct.
Yeah, but you see, at the end of the day, you have the same thing.
Yes, sir.
Yes.
So yeah, if I didn't do it, this guy would be like, you claim this solution. But I don't find this friends. Okay, my brother, this is it. I don't know. Just tell me something from whatever you see here that you feel you have escaped. I didn't forget your question. I'm not running away from it.
Yes, no problem, sir. I'm also like giving Koketo a chance to choose if she's also.
Yeah. Okay, so any question that you feel like any okay, let me bring it from the beginning and I'll scroll up bit by bit. We cannot do all of them. I wish we started earlier. You paid me and I was gonna because
I,
Mm,
it's not a problem, sir, because at least now, even when we're done, we can approach the questions with some new knowledge, and like
yes, like you gave us an idea how to approach certain questions and all those things.
I'm
So I feel like
available.
right now is much clear.
but
Can
sir, I think we should do a force vibration
a force
with a
by
temp
with
with
a
a temper.
damper. Okay, for instance, which one? Okay, this one doesn't have a damper. I want something with a damper. This one does not. Does it have?
It has a temper, it has a spring, but it has a forcing
Okay,
force.
no problem. Should we let's do this one quickly then? What do you think, Koketsu?
Okay, it's fine. It's fine with me.
Hey, this
And
guy.
then, sir, if you do get time, can you also just, if you can explain the logarithmic decrement, something like that?
Yeah, I think this is the question about it. It has it. You can,
Okay, perfect.
guys. You see this effort that you are making me do. You need to pay me.
Yeah.
I go. I don't have anything to prove, my brother. I've proven already.
But you have something, sir. You're gonna go forward with it.
With this thing. Ah, hey, my mind is on money, bro. This education thing.
You're chasing the bag.
I
Just
know.
don't
Hmm?
just don't fall victim like of a scam, sir, because I've been falling victim of scams also.
Hmm. I know I'm good in this thing. I know I'm very good. It's not even something. I know I am.
We can see that you are.
Hmm. But I don't know if this thing has money. Following student to pay. What? I key stress.
You just need a personal assistant, a real one
I
that's
have a
gonna do.
manager.
Yeah, the manager must do his job correctly.
Now, so far we have built. You see, you shouldn't have to. Okay, at first, before our class, when I meet you in class, what did you say? You asked me if I could do. So, what happened is, I had to come and give free classes just to prove that I can do it.
Yes,
I didn't
yo,
want to do that like that, but I had no choice because I cannot just come to you and say, give me money. We are allowed.
yes, sir.
Yeah.
So, what happened during that time, I still pay my manager, even without money.
Yo, but like I said, sir, things will come right.
Yeah.
But you need to now broaden yourself. Like you have to get your online presence sorted out so that you can like go to do other universities as well. Students from all universities.
Yeah, that's the thing about it. Actually, that's the crazy thing that I have in mind, but it will take time, maybe a year or 2 or 3. It's just to create a website where you have explanation and people pay subscription. I know someone might steal my idea as I'm speaking it.
So you want to that's separate from what I'm saying because that would be like shake, like homework help. But I mean something like like what we're doing right now, where
Hmm.
someone is paying you for that, like a student by Wits
Yeah,
as
that's
well.
quite true. I think I can do that. I can catch my bus, go went to Vert, put my prospectus there. It's just about trying.
That's it.
Hmm. Okay, but let's not waste time. I know tomorrow you also have work. A rectangular bar of this as a mass you can see the rectangular, it has a mass, right? And what did I say? Anything that has a mass have what? Moment of inertia.
Acceleration.
I mean, yeah,
Moment of inertia.
Acceleration was when we had linear motion. In such horizontal motion, you don't have to worry about it. You just keep the concept in mind that when you have a mass, you do have moment of inertia.
Okay.
A 50 Newton force static applied at point P. Where's point P? At the bar at P. Where is P? Do you guys see P?
It's at the end, sir. There where the 50 is applied.
Okay, we guess it's there. And then
Yes.
removed. The initial oscillation of P are monitored, and the accelerator and the acceleration data show where the time scale kilometers. Okay, and but oh guys, so forgive me, I can't read what I see, but you can read. They say the period of the damped free vibration. What is this period? The period of the damped free. What if you are damped free? It means the part without the damper, right? When you have sugar free, it means there's no sugar. Key English, nothing hard here. Damped free without damper. Damped free
Yes.
vibration is determined from the accelerator. This is the accelerator. How do we do this again? Okay. By the accelerator, time 0,1 as 0,1 second. Okay, at 0,1 second. This is where we are. They said it can be shown that the following equation can be used calculating logarithm decrement. Okay, we'll see. First question, they said determine derive the equation of the motion. That will always be the first question, even when it is not asked. When you have such a drawing, you first draw the FBD, free body diagram. So let's do it quick, guys. Let's do it quicker. Okay, for the FBD here, remember if the force is here, it means you are applying direction to go down, right? And always choose down direction as positive. It means this is your bar on the free body diagram. You first show the first reference, which is this one. Do you agree?
Yes.
Now you have it as it is moved. If this is the pivot, this movement will be done where the pivot is. The bar was moved like this. Sorry. Let me use technology. Why is it only turning there? Okay, let me draw. Technology.
Technology, man.
What is it doing? Hey guys, this thing is okay. Sorry. I haven't not yet mastered this technology here. But here's the ruler. Yeah, I think it would be cleaner like this. Technology. Now, this is a nice line. I'm happy, my brother. I'm happy. Now I'm excited, you see. Can move it here. Take my ruler. This is nice. Dot. Ooh, this thing is making my night.
Yeah, I think I need that too also.
Okay, guys. Okay, this is the bar after it has been done. Remember, this is the pivot point here. Ooh, this thing is nice. Oh my god. Now, if we draw the free body diagram, this is the force, right?
Yes.
Remember, the spring is here to oppose. If you have chosen this direction as positive direction, so if you have to oppose, where will you go?
Up.
Up. So here
Anti-clockwise.
you have Fs. Don't even worry about anti-clockwise. Just keep the consistency. Remember, you deal with the system in two modes. This is theta. This is also theta. Do you agree?
Yes, sir.
So now, what's happening here? The same consistency move that you have here. Remember, it is the same thing directionally. You don't change it. This is the damper. The damper is also here to oppose. Where will it go if it has to oppose? Up or down?
Down.
Do you see it, Koketo?
Yes, I see.
It has to go down. You deal with it different part. You deal with this section and you deal with this section. But remember, you keep the consistency of your motion. If I am on this section, if I have to oppose, where will I go? Down.
Go down.
But remember, you also have the weight of the bar. It's the free body diagram. At the center of the bar, you put weight bar. If you do this, this is usually 3 marks. But like I said, when it comes to moment, we will not include the weight because it cancels as static equilibrium. But you have
So, sir, the weight. Oh, it's not by the pivot. Sorry.
It's not there. Definitely, you have what we call a parallel theorem.
Yes, sir.
You see, guys. Now you go some of the moment about the pivot. You can call this pivot O at the center here to be what of all the forces to be moment of inertia times what theta dot dot. Do you agree?
Yes.
What are the forces here? You show you have moment of Fd plus moment of weight bar. You write like this. You don't care about sign first. You write only.
Most moment of
Fs.
F.
Moment of F.
What is that second one? Moment of
Weight.
weight. Okay.
You won't include it in the solution because you know it cancels as such, but you show that these are the moments that you see under this system.
Yes, sir.
But as you solve, you don't have to write it down. Don't worry about it. Now, what is Fd? Fd here, what is the moment? It is force times what?
Force times the perpendicular distance.
Okay, and you can see this thing from this figure here. You can see it here. If this is Fg, what is the perpendicular distance?
0.65.
Now,
0.65.
remember, how is Fd? Is it going same direction as chosen or opposite?
As what?
We chose direction.
No, I'm saying as which direction?
As the chosen direction. This is the chosen direction. Where is Fd?
It's going in the opposite direction.
Definitely is negative. Look, Fd is equal to C multiplied by x dot. Fd goes with velocity. Fs is equal to what? Kx. Do you agree? Let me move the date. It's
Yes.
Kx.
Yes.
Now, it is negative because these things will always oppose the motion. That's the first rule.
Yes.
And you can also see it from your free body diagram. So here I can confidently come and write Cx dot. Do you agree, Sisi?
Yes.
Yes, I said we forget about the weight. It cancels as static equilibrium. We don't even have to worry about it. Let's move to the, okay, C times x dot multiplied by the distance. Remember, moment is force times what? Perpendicular distance. What is force? This is the force, Cx dot, right?
Yes.
So the distance, I hope it's not confusing you guys.
No, sir. Everything is still fine.
Are you fine, Kwekwezo?
Yes, I am.
For the spring, you're also gonna have, if the spring is here, what is the perpendicular distance?
1.95.
1.95.
So you're gonna have minus kx multiplied by what?
1.95.
Easy as that, guys. Okay, force. How is the force? It's positive, right? It's going, is the one leading the direction.
Yes.
If the force is here, what
Yes.
is the perpendicular distance?
If the force
1.95.
1.95.
Yeah, so you agree you can write F multiplied by 1.95. Are we good? Now
Yes.
we
So
need.
wait, I just wanna, I'm just a bit confused there with that 1.95.
Technology. Let me zoom for you. Uh, this is the pivot, right?
Yes.
This is F. This is the force. What is the perpendicular distance? From here.
Yeah. No, I see it now, sir. Thank you.
Okay, it's just technology, my brother. It's technology. Now, what else do we have? Okay, now it's about dealing about x dot. Okay, let me explain to you how it works. Remember, when you are here, this is equilibrium, right? This dotted line.
Yes.
Do you agree it's
Yes.
equilibrium? When you move this,
Yes.
when this thing shift, remember I've said the spring create what? It create
Angular.
displacement. X. What is the displacement x? It is r
It's
theta.
RP.
What is r? R is simply the distance where the pivot is. Look, this is the spring and this is the pivot, right?
Yes.
Do you agree? This distance, let's say it is r, right?
Yes.
When this thing it is shift to a certain dimension, do you agree it is the same r that is making an angle of theta?
Yes.
Yes.
That's one of the reasons I said earlier on that your moment distance, that distance will be that distance that will create the r. I hope you see what I
Yeah.
was meaning here, or what I meant. That's the good English, not meaning.
Yes, we see.
My brother, what I was trying to say is x here, in this case here, we're simply gonna be 1,95 theta. You will notice that this distance here, this 1,95, is the same as the distance of the moment. That's what I was saying, that this thing will always be square.
Wait, sir.
You are
The R
confused.
theta. You're saying that R is 1.95.
Mm.
Um, how did
No.
we get that?
Yeah, that's what you're supposed to ask me. What is
Oh,
the
but I get it, sir, because it's turning by the center point is the pivot.
is the pivot?
So that's basically the radius that
This
you're
is,
calling
yeah, this basically,
1.95.
this is where the spring is. If the
Yes.
springs moves, it's still gonna be 1.5 now. The only difference now is the angle.
Yes, sir. Yes, sir. No, I'm with you now.
That's what I said. If you see what I was saying is the distance that gives you the moment is the same distance that create the r.
Yes.
Okay, sir.
Key trick, key. Oh, yeah, something like that. Now here's the same thing. Remember, I've showed you that x is equal to r theta, x dot is equal to what? R theta dot, x dot dot is equal to r theta dot dot. If the damper here is x dot, do you agree that it's going to be r theta dot, right?
Yes.
But what is the
Yes.
distance of r here? It's simply where the guy
1.95.
is.
0.65.
Do you see it, Lorenzo?
Yes.
It's 0.65. So it means that here
0.65 and 0.65.
that's what I'm saying. It will give you, it will always give you square, guys.
Wait, yes.
If you get the trick, guys, I say the trick is the distance that gives you the moment. That same distance gives you your r. Either it's
Yes.
r theta or r theta dot. It is that same distance. And I even said in class, if you don't get a square, it means you are making a mistake somewhere.
Yeah.
But you were not in class, I understand. You'll be having minus c. Is it okay if I write 0.65 square theta dot?
Yes, sir.
Is it okay, guys?
Yes, it's okay.
So here you also have k 1,95 square theta plus F 1,95. Now you are done with the moment. So if you understand this, you can skip this much. You can just say, that's even the trick I give people. Sometimes you don't even have to look at the drawing again. You can just see this distance is the one creates the moment. I can just square it.
Yeah.
You don't have to worry about thinking much. This will
Sometimes, sir, that when it shows 12 marks, you try and write 12 lines.
okay, yeah, that's also.
Just to get
But
some
but
marks, more marks.
but what I'm trying to show you is at least you can track that I'm on the wrong way or good way. If you don't see that square and you know it has to be a square there, you can force it.
Sir,
Sometimes.
that's what I was doing before we had this class. I was just squaring them. I knew it had to be square for some reason.
Yeah.
Yeah, but sometimes you just have to force life. And it works sometimes, my brother. But don't force anything. Everything. Force what is forcible. Force for a job, force for a position, but don't force for a girl or whatnot. Don't do that. Now, what is next here? Okay, we have the equation. What is next is this part here, moment of inertia of the system. What is moment of inertia of the system here, guys? How many masses do we have? Sometimes.
One.
Sometimes it's one. What is the bar? Do you agree, Sissy?
Yes.
It's simply I bar. Okay, I wanted to say sometimes they give you maybe mass of the damper or mass of the spring.
Yeah.
If you have mass of the damper, we call it, if you had concentrated mass in a problem, the mass of the damper is taken as a concentrated mass. In that instance, I damper will be the mass of the damper, the distance where it is to the pivot square, which is what?
0.65.
The spring also have a mass if it is given, but the spring,
Yes.
you always divide that mass by 3 distance
Okay.
where the spring is to the pivot square. Why do you divide by spring? Because practically the spring is very light that the mass is negligible.
Okay.
When you solve it, you divide by 2 just to show that it's negligible. That's why in most of the problem they don't usually give you these masses. But if they are given, remember that this is divided by 3 before doing the constraint mass. This is taken the way it is.
Okay.
In this case here, because we don't have masses, that's what I said. If you hear any masses information, it means you do have what? Moment of inertia.
Inertia.
Well, as I'm here, I'm just thinking, what topic can I put under this on my YouTube channel? Like what topic to this problem? I'll just put single degree of freedom problem. Yeah, I'll just do it like that. Now,
Yes.
it is I bar. Okay, what is I bar? You see, remember what I've said? Center of gravity of the bar is at the middle. Do you see? Do you agree that if this is the full length, the middle is somewhere here?
Yes.
Do you agree, Sissy? Let me use my
Yes.
color again. Technology. This thing is making me happy. I don't know. Key 90. Where is 90? Key 90. We're almost there. Key 90.
Let's use technology.
It's nice technology.
This thing is just making me happy tonight, but I feel like I'm gonna sleep nice just because of this. Hey, why are you shaking now? We are shaking, eh?
You're pang.
Anyway, it's fine. Let's remove the ruler. Okay, what I was trying to say, let's say this one is the center of gravity of the bar. Do you agree? Where is the pivot?
Yes.
Now, what do
The
we do?
pocket is next to it.
You know that because these two lines are parallel, you know that you have what?
Parallel theorem.
So first of all, you have 1/12 mass of the bar, length square. Do you agree?
Yes. Yes.
Plus mass of the bar. Now, remember length square is The total here is L. You know what is L? L is this plus this.
Yes.
So now, what do you need? You need this distance here. Let's call it R. How do you get R? R, as I see here, it is simply 1,95. What am I saying? How do you get R? Yeah, that's the good question.
Minus R.
No, R is the unknown. We need to get R. We need to get okay, I see what's happening. First of all, you guys need to get the distance in the
Oh,
middle
it's
here.
half of the bar because
What is
no.
half of the bar? From here to here is half of the bar.
Oh.
It's just some mathematics, Niana. Nothing electric.
Yeah.
What is this distance divided by 2? What is this?
So
plus
meaning we
this?
say length
1.3.
divided by 2 minus by 1.95.
Yeah, and then you get this distance, this R.
So you get half, which is 1.3, and
Okay.
then you minus
You
0.65.
get, it is 1.3, right?
Yes.
So what you'll have is 195 minus that 1.3. Remember, it gives you this small key, this small thing here.
No.
That's it, guys. That's it.
No, sir.
Do you see it?
No, sir. It's 1.3 minus 0.65. How I
Is
don't
the
understand
length
it also now anymore because yeah, it's right. 1.3.
Remember? What is this distance? What is, okay, to get the middle of
length?
this bar, 195 plus 065 divided by 2. What is the answer?
1.3.
It gives 1.3. 1. It means from here to here is 1.3. From here to here also is 1.3. We all agree.
Yes.
Yes.
So what are you saying? You are saying that it is 0.65. It is 1.3 minus 0.65.
Yes.
You get the same answer. Or it is 1.95 minus 1.3.
Minus the 1.3.
I get it now, sir.
Either way, you are free to do your math there.
Okay, sir.
If you go like this, it's gonna be 1.3 minus 0.65. If you go from right to left, it's 195 minus 1.3. I guarantee you.
I see, sir.
So yeah, don't get confused there. I'm left with 15 minutes. Let me explain it quickly. So okay, what you guys do here? Remember, if you have an external force, your equation should be equal to the external force. I'll
Yes,
explain
sir.
what I mean. So what I mean here, what we'll have here would be minus C 0.65 square theta dot minus K 0.95 square theta plus F of 1.95 to be equal to what? IS multiplied by what? Theta dot dot. That's what we said in the beginning. Do you guys see it?
Yes,
The
sir.
only
Yes.
difference is we have already calculated this. That one you'll do it, right? You can just punch your calculator, right?
Yeah.
Don't forget the unit. It's kg meter square. Now, what do? You make sure that the force is alone. Do you agree? So if I have to make sure, I'll simply bring is theta dot dot. All these guys here will move on my right there. I'll have plus C 0.65 square theta dot plus K 0.95 square theta to be equal to what? To F 1.95. But remember, guys, what I said is when you solve this type of equation, this guy should always be alone, theta dot dot. So you divide everything by is, right?
Yes.
So that you can get your differential equation. No, guys, you this content cannot be free, my brother. This nice content, my brother. Even Joseph Dari cannot do something nice like this.
Right.
I agree.
He cannot, my G. This high level.
Right.
The time is even flying, sir. Like we just doing like 10 minutes of work and 1 hour is gone.
Okay, guys, you divide everything by is. Remember, now when you have theta dot, you have 2 zeta wn. Zeta is the critical, is the damping ratio. No, damping factor. And this one is wn square. Now you do this, you have this full 6 marks. I think I'm left with 10 minutes here. 12. Yeah, we can finish this in 12 minutes. The good things, you guys have an idea of what's happening here, so I like it. But there is something that is important here. They said to get what? We have 2 unknown. We don't have c, we don't have k. But they said if the value of the logarithm decrement is to determine from accelerated data from one consecutive cycle. Do you know what is one consecutive cycle, right? Find in the data.
One consecutive means
N equal 1.
n equals 1.
Sorry, Mr. G. In other way, the way you can say it, the way you can see it from here, to have a consecutive, if you have hey, why is this thing what freezer, eh? Hey, guys, why is this laptop freezing now? Since when does it do that? Okay, you see head.
It's gonna come.
Let's give it 1 minute. Let's give it 1 minute.
So, sir, what those forcing excitation forces and stuff that there's
It's the
sign
same
and cause.
principle.
So, sorry.
Okay, ask your question again.
Yeah, I'm saying with those questions where we have sign and cause forces, like being our excitation forces, do we go about it the same way, like with the moment
It
story?
is the
We
same
enter it
way. The
exactly
only
the same.
difference is you have the exciting force that comes with some WT. There they can ask you for amplitude or what. But what I will do, I don't think I will sit down and solve a full question tomorrow morning for you.
No, it's not like I believe that you helped us a lot, sir. And like there's also the exams. There's also test 2.
Yeah.
There's also test
Guys,
3.
I don't
We
know,
have a lot.
but this app is not responding here.
Yes, sir.
Oh, it's
Yeah,
back.
but
Oh, it's back.
like I said, it's not a big deal. You can even just discuss it, sir. I believe so.
One consecutive from here to here, it makes one consecutive from head to head. It is n
Yes.
equal 1. It's a full turn. So logarithm decrement. Sorry for writing like this. The logarithm decrement, I think it is 1 over n, the ln of xn plus 1. Okay, xn is the highest amplitude. Basically what you do from the graph. What is n? They said n is one consecutive, right? N
Yes.
equal 1.
Yes.
Do you agree?
Yes.
So you have 1 over 1. The ln of what is xn and what is xn plus 1. That one you see it from the graph. So xn is simply, you can see here, guys, is the highest
3.
amplitude. Or should I use the technology again? Yeah, this thing is freezing. I don't know if it's taking too much. Oh, I think it does that when I've been writing one informations a lot. Like I've been writing a lot on my Microsoft whiteboard. It does that. But what you can see here is the highest point is what? It's at 3, right?
3.
What is the second
Yes.
point? 2. So
Yes.
your xn is 3. Your xn plus 1 is 2. So that will give you
Minus 2.5, or is it 2? Or you don't look at the bottom one.
no. Remember, it's a cycle, head to head.
Okay.
I don't know. I want
Not
to
head to trough.
No,
Not head to trough.
You start up, you finish up. One cycle.
Crest to crest.
That's the English, my brother. You have good English. You just want me to say head to head or what?
I don't know. I'm just showing you that I'm with you, sir. But okay, I get it, sir. And then so now we have to pay perfect attention to what when they say successive or consecutive because of this
Okay,
reason.
successive. For me, is the same. They are, how do we call it? They are synonyms. But I went to consult the lecturer. He said when I talk of two successive, it's n equal 1. Two consecutive is n equal 2. So just get it like that.
Two consecutive
If I
is
said
two.
two successive, n equal 1. If I
Okay.
said three successive, it means
N
n
equal
equal 2.
two.
But consecutive, when you hear consecutive, what you hear is what you get.
Yeah, what you hear is what you get.
Yeah, that's what I mean. Two consecutive is 2. Three consecutive is 3. But two consecutive is 1. No, two successive is 1. Three successive is also 2.
Now, what about this? With this 50 newtons here, where would I now be able to see my acceleration there?
Which
Or yeah,
acceleration? I need to understand your question.
because normally we would have the differential equation equal to like let's say something cos.
No, that one
Uh,
is when you have an exciting force, where you talk of amplitude. My laptop just froze
yeah,
now. If you don't have
yeah, like
if you do not have an exciting force in this case, you will deal with it the way it is. You don't have to
the
worry
way it
about
is
it.
with 50.
This will give you logarithm decrement. Now,
Yes.
the question was to solve, I think, for C or K. It's easy to solve for C. You know that 2 zeta Wn will be equal to C 0, 6 square over is. Do you agree?
Yes.
Yeah.
You will make C subject of the formula. The only unknown that you have here is the damping factor. I mean,
Yeah.
zeta. How do you get zeta? There's a relation between logarithm decrement and zeta. Are you in the group of ICE education?
I know that thing is where I think the logarithmic it's and then you have 4 pi squared stuff.
Let me send. I'm sending you the formulas personally on your WhatsApp. Those formula sheets.
Yes.
You will see that there's a relation between zeta and what zeta here. Sorry, I don't know how to write it. It's
Yeah, I
logarithm
see.
decrement over the root of 4 pi square
Pi squared.
plus zeta square. So what does that mean? The value of logarithm decrement that you got here, you substitute here, you got zeta. They are constant, they are unitless. You don't have to worry about the
Then you
unit.
can get C.
And if you get zeta, you can get C.
Okay.
Do you see it
So
correct?
so with the exciting force, with the term in front of the cos or the sine. For linear, it would be linear acceleration, and then for angular, it would be angular acceleration
I
by
don't
the
understand your
exciting
question. I
force.
need to understand. I need to answer what I understand. Repeat again.
So, sir, let's say I have an exciting force of F
In
naught
4 minutes, I think I
sine.
can answer you in 4 minutes. Okay, talk. I'm checking one here that
So
has it.
anyone with the exciting force, sir, just check with anyone with the excitation force.
Yeah, I'm listening to you. I'm
Yeah, so
looking.
I just want to know what is the form of the excitation force, like
My
the
laptop is
what
freezing.
like how we read W the natural frequency
No, W
from
is not the
theta.
natural frequency.
Okay, so that what is WN
Hmm?
omega n? What is omega n, sir?
Natural frequency. It's caused by the
Natural
spring.
frequency.
The spring is the one responsible of that side. Wn.
Yes, sir, so you get it from theta.
From
You
theta,
get it
yes.
from in front of theta.
Yeah.
So what is in front of the excitation force? That's what I'm asking.
Oh, what is in front of the excitation is gonna be that force multiplied by distance, that moment there.
The moment, so it's there's a force in front.
Remember when you calculate the moment, because my laptop is freezing, I don't know why
Yes,
it's doing
yes.
that.
Then it's force times the perpendicular length.
You forget about the sign. You're gonna have that force multiplied by the perpendicular distance. That force, I think in your book they are calling it alpha zero. You use it to get the amplitude.
So it's a force, alpha zero.
Yeah.
That's what I'm asking, sir, because I get alpha zero and then so F zero is a force. It's the
No, what
force.
what makes it the force is when you have, remember, when you have an exciting force, is F chi is equal to F sine or cos, right?
Yes.
When you get the moment, that F multiplied by the time, by the distance give you the moment. Do you get me?
Yes.
But remember, at the end you divide everything by moment of inertia.
Yes.
Everything included on your right
100%.
and moment of inertia.
Yes.
That's the one that gives you alpha zero.
Yes, sir.
That's the one that you use to get the amplitude and everything.
Amplitude. So that is amplitude. Thank you, sir.
No,
Thank you
that's
so
not the
much, sir.
amplitude. That's the one that you use to get the amplitude.
Today I know what the X. Yes, sir. I
Yeah.
know.
Okay.
Sharp.
Thank you guys. Thank you.
Sharp, sir.
Thank you so much.
I will post this on my YouTube just now.
No problem.
Okay, so where do I find your YouTube link?
I will. Are you in the group? Okay, I will send it to you personally now.
Okay, I'll appreciate that.
It's a 2 hours
Sharp.
video.
Very good, sir.
Sure.